So far we've been looking at asset returns that are normal. So asset returns that are normal. And this means the asset prices. The prices are log normal. Is this realistic? Let's take a look. Let's draw a graph. And we plot the daily returns of the S&P 500. So we'll get something like this. A little bit of noise in the data here. So we'll get something like this. And then if we fit a normal curve to this, get something like that. So this is the best normal curve. And we think, well, it's not terrible, but it doesn't really fit exactly. So the tails are a little bit off. The middle is not quite as peaky as it's supposed to be. And maybe this isn't such a good idea to use the normal distribution. In fact, if you start looking at extreme events, so let's look at the percent chance of a 20% drop. So these are daily returns. So this is the percent chance of a daily 20% drop. In reality, the chance will be 0.000165. And that'll, be very rare, but it does happen. And it'll happen about once every 25 years. If we ask the same question for the normal distribution we just did, the best fit normal, our chance is actually 1.8 times 10 to the negative 79. So this is a very, very, very small number. And that will only happen once every 2 times 10 to the 76 years. And so we look at this and we think, these are very, very different numbers. We're not just a little bit wrong. We're really, really, really wrong if we look at the normal distribution that best fit the data and ask questions about these extreme movements. This is staggeringly bad. Staggeringly bad at extreme movements. So this is bad news, because we've been using the normal distribution as an assumption in doing all our math and doing all our formulas. And now we're seeing that it's actually really a bad model for these extreme events. And they happen. They happen every, 20% drops happen every 25 years. 5% drops happen even more often. And if we're using the normal distribution, we're getting entirely the wrong answer. This isn't like a factor of 10 wrong or a factor of 100 wrong. This is really, really wrong. So this is not good. So why did we ever even use normal distributions? Maybe it's just a totally bad idea. Actually, it has some basis. So if we look at the central limit theorem, the central limit theorem basically says that if you take some distribution, so let's draw some little distribution here. I'm just making some random distribution. And if we sample multiple times from the same distribution, we end up with a sum that is some normal distribution, bell curve. So multiple copies of this little random distribution end up going to a normal distribution. And so you start thinking, well, how does this apply to the stock market? If you look at daily returns, there's lots of things that happen during the day, and you add up all these little events that happen, and that gives you your daily return. And so even if the individual little things aren't entirely normal, as you add them up throughout the day, you end up with a normal return. Then you add up the daily normal returns to get other normal returns for weeks and months and years. And the central limit theorem basically keeps everything consistent. Normal works for everything. If we thought maybe there's some market microstructure and it skews the distribution for small time scales, that doesn't really change our model. You just add these up and you still get normal distributions. So that's why we're using normal distributions, because the math all works out nicely. But then when we look at reality, we get this behavior where the extreme movements happen much more often than they're supposed to, according to our normal distribution. So what can we do? So one choice is to use another distribution. Maybe. So if we use another distribution, we actually hit some problems pretty quickly. So one is that the math gets hard. And that doesn't just mean that the formulas are more complicated. It means we start getting things like standard deviations go to infinity. So like we no longer have any way to talk about volatility or standard deviation in returns. So that's a problem. A consequence is we can't do delta hedging. So if there's no delta hedging, we've been using delta hedging for almost every formula we've been doing. So this means that we have to invent totally new models. We can't do anything that we've been doing before. So this is a real problem. But you can do this. It's, one way to proceed. Another way to proceed is to keep the normal distribution and realize that these extreme events are not modeled correctly. And so always keep in mind that these extreme events are much more likely than they seem to be based on the model. And, make sure you have backup. So when these do happen, you're not left blowing up. All right, so we've been looking at normal distributions and how they don't work correctly, but we use them anyway. Pretty cool.